6.2 is going to be over inverse functions. Okay, before we talk about inverse functions, we must first talk about a one-to-one function. Okay, a one-to-one function is first a function. Whoops. A function, so it has to follow all the definitions of the function, where every element of the range also corresponds to only one element of the domain. Okay? So, it has to first be a function, and then by looking at it saying, is this a function, we're looking for any repeated x values. If we have any repeated x values, then it's not a function. Then we need to determine if it's one-to-one, so we'll be looking for repeated y values. If there's any repeated y values, it's not a one-to-one function. Okay, so let's look at some examples. So these, before it's a one-to-one function, it must first be a function, then it'll need to be one-to-one. So we're looking for repeated x and then repeated y. So if you look at this one, it is a function because there's no repeated x, but it's also one-to-one because there's no repeated y. So this is a one-to-one function. I'll use the little notation 1-1, just it's shorter than writing out one-to-one every time. Here's another example. Okay, this guy is a function, but you can see right here we have repeated y. It is a function, but it's not one-to-one. Function, but not one-to-one. Last example. You can't just skip straight ahead and look for repeated y, because it needs to first be a function. In this case, you can see right here we have a repeated x, so it's not a function. So by extension, also not one-to-one. Okay, and so we had the vertical line test for functions. We have the horizontal line test for one-to-one. They must pass both. Okay, must pass the vertical and horizontal line test. So here's an example. Here you can see that this passes the vertical and horizontal line test, so it's a one-to-one function. This guy, though, it passes the vertical line test, so it's a function, but it fails the horizontal line test. So it is a function, but not one-to-one. And then something like this, it's not a function, so it's not going to be one-to-one either. Not function, so not one-to-one. So what's the point? Why are we talking about one-to-one functions? Well, the whole lesson's about inverse functions. Come to find out, you cannot find the inverse of a function if it's not one-to-one. You cannot find the inverse function. So a function must first be one-to-one before we can find the inverse function. Okay? So, if we have a function, a one-to-one function, f of x, we say its inverse is f inverse of x. And that's how we read that, f inverse of x. So what does that mean? Basically, everything's the opposite from one function to the other. So the excuse me, the domain of f of x is the range of f inverse of x, and vice versa. The range of f of x is the domain of f inverse of x. Okay, one really cool thing about this is inverses undo each other, and we talked about in the last section of how we compose functions. So whenever you compose the two, they undo each other, and that's our way of combining functions, compositions. And you end up with just x. Or also, going the other way with it, you get just x. Okay? So, we have a little process. For finding f inverse of x. Given f of x is 1 to 1. That's important. It has to be 1 to 1. Okay, so first we can just graph it, and by visual inspection we can determine if it's 1 to 1. That's the first step. Okay, here's the steps. There's only 4 steps, and 3 of them are very easy. First step is change f of x to y. Second step is switch all x and y. Step 3, solve for y. That's the one that can be kind of lengthy. And step 4 is change y to f inverse of x. Okay, so let's do some examples following these steps right here. Let's say I have f of x equals the cube root of x cubed, no, that's not what I want, of x plus 3. Okay, so following these steps, we first change f of x to y, switch x and y, then solve for y. So if we cube both sides, we get this, subtract 3, we get that, and then that tells me the last step is to change y to f inverse. We get f inverse of x is equal to x cubed minus 3. Okay, let's do another example. Let's do f of x equals 2x plus 1 over x minus 1. This one's a little bit harder to solve for y. Okay, step 2, we've already changed f of x to y. Step 2 is switch all x and y. That literally means every single x becomes a y. So we have to change both those guys to y. Now we got to solve for x. Now, we can always get rid of a fraction by multiplying by the denominator. So this is going to give me x times y minus 1 equals 2x plus 1. Okay? Now, where do we go from here? We want to isolate x by itself. I'm going to go ahead and distribute, or excuse me, y. We want to isolate y by itself. Let's distribute this x right here. Now if you look, the only thing that has a y in it is this term and this term. So we need to put them on the same side. If I put those on the same side, I have that. Now, x and 1, they're fine. Let's go ahead and put them over on the same side just to get them out of the way. Now, at this point, I can factor out a y, and then whenever I do that, I have isolated y by itself because I can divide by that quantity and solve for y. So then, f inverse of x is x plus 1 over x minus 2. Okay? Now, Let's go back up here and look at this rule right here. I'm going to use this example here. That f of x and that inverse. Let me bring them down. If I do f composed of f inverse, that's going to be f of f inverse of x, which is going to be the cube root of f inverse of x plus 3. Plug that in, the cube root of x to the third minus 3 plus 3. The minus 3's plus 3's cancel, and I end up with the cube root of x cubed, which is just x. It works the other way as well. Plugging in f of x into f inverse, then replacing that guy. Cube root and the cube undo each other. The plus 3 minus 3 undo each other, end up with just x. Okay, now that was just proving that it works. How can we go a step further? Let's say I tell you g of x is, say, like 1/2 x plus 4. Oh, that's f of x. And g of x is, say, oh, what happened? Let's say g of x is 2x minus 8. Okay? The question is, are they inverses? Well, the easiest thing to do is find f composed of g and see if it equals x. Okay, let's try that. So that's going to be 1/2 of g of x plus 4, 1/2 of 2x minus 8 plus 4. Multiply by 1/2, we get x minus 4 plus 4, which we get x. And then that proves to me that f and g are inverses of each other. If it was anything plus x, I mean, like, let's say it was, I don't know, x minus 16, they would not be inverses if it's anything besides that. In this case, it was just x, so they are inverses. Okay, so let's stop there.